In this practice, we'd like to write 3 equations using the loop rules. Before solving these questions, I'd like to explain the loop rule. Loop rule says the algebraic sum of the potential difference sits in any loop, including those associated with EMF and those of resistive element must be 0. So this is the loop rule. So if you sum up all the voltage drop, it becomes 0. This is the loop rule. First of all, we'd like to determine the direction of the loop. So if you consider this is the direction of the loop, then if you find this EMF, this becomes positive epsilon. If the positive pole and the negative pole is opposite directions, you have to put a negative sign because the directions of the positive pole and the negative pole is opposite. So this is positive and the negative. So depending on the directions you choose as a direction of a loop. So if we consider the resistor, then if the current is the same with the direction of the loop, in this case is a negative IR. And if the direction of the current is opposite with respect to the direction of the loop, this is the positive IR. So you have to be careful about this sign. Then we can go back to the original questions. So I have to write on the same network. Okay, this is a resistor network. Then, at first, as I said, I'd like to find the directions of a loop. So, what kind of a loop we could consider? First loop. For example, this is the biggest one. Is the loop we could consider. Once we consider the loop, you have to determine the direction of the loop. This is the direction of the loop 1. Then second loop, you could consider you have to return to the original point and finally come to the original point. Then you have to determine the direction of the loop. Number 2. And then third loop, you could consider this is the third loop. And return. This is the directions of the loop. This is the third loop. And then then we have to determine the direction of current. How many current we need? So maybe it's better to start with these two resistors. So in this case, the independent current is flowing in these two sides. So this means if you consider these junctions, then the sum of the current should be flowing I sub 1 and I sub 2. And if you want to consider the current here, and the current here, and the sum of these two currents have to be the I sub 1. So maybe it's better to introduce a new current I sub 3. Once we introduce I sub 3, you can easily find this is gonna be I sub 1 minus I sub 3. Then I sub 3 and I sub 3, if you consider this junction, the current should be the sum of the two currents. I sub 2 and I sub 3. We have three unknowns. I sub 1, I sub 2, I sub 3. So this means we need three equations. Needed to solve these three unknowns. So this is the reason why we need three equations. First loop, second loop, and the third loop. Then for the first loop, you should start with this loop. Then first one is passing through this voltage drop batteries. Then it corresponds to this part because passing to the positive. So you have to put a positive sign. So this sigma B equals 0. This is equal to the epsilon. And come to these regions. And then at first we meet the first resistors. And the current is the same direction with the direction of the loop. Then you have to use this case. You have to put a negative sign. Minus I sub 2. So I forgot this is R sub 1. This is R sub 2. R sub 3. R sub 4. This is R sub 5. So I sub 2, R sub 2. And come to this direction. And then we have another resistance. So you have to use a negative sign. I sub 2 plus R sub 3, R sub 5 equals 0. This is the equation for the loop 1. And we do the same calculations for the loop 2. First one is epsilon. This is passing through. This is epsilon. And come to this region. Now resistor 1 is passing minus I sub 1, R sub 1. And in the same direction of this current minus I sub 1 minus I sub 3, R sub 4 equals 0. For the loop 3, loop 3 is the inner loop. So first resistance is I sub 1 and R sub 2. Is the direction is exactly the same. So this is minus I sub 1, R sub 1. And the next one is second resistor is R sub 3. And the direction of the loop is exactly the same with the direction of the current. So put a negative sign. I sub 3, R sub 3. And come to the third resistors. In these cases, direction of the current is opposite to the direction of the loop. So we cannot use a negative sign. This is negative, negative. The last one should be the positive because we use this last case. Direction of the loop is opposite to the direction of the current. So we have to put a positive sign. So positive I sub 2 R sub 2. So current is I sub 2 and the resistance is R sub 2. So positive equals 0. So using these three equations, this is the answer to this practice. Using these three equations, we could discover the equation of the I sub 1 and I sub 2 and I sub 3. Then I'd like to show you just only the answers. I sub 2 is expressed using the I sub 1 and I sub 2, I sub 3. I sub 1 R sub 2 plus I sub 3 R sub 3 over R sub 2. And the I sub 1, this I sub 1 is written epsilon over R sub 1 plus R sub 4 plus I sub 3 R sub 4 over R sub 1 plus R sub 4. Now all the term is expressed I sub 3. Finally, I sub 3 sub 2 R sub 4 minus R sub 1 R sub 5 over R sub 1 R sub 2 R sub 4 plus R sub 1 R sub 4 R sub 5 plus R sub 1 R sub 2 R sub 3 plus R sub 2 R sub 3 R sub 4 plus R sub 1 R sub 3 R sub 5 plus R sub 3 R sub 4 R sub 5 plus R sub 1 R sub 2 R sub 5 plus R sub 2 R sub 4 R sub 5. So actually this is continuing. Okay, this is the R sub 3. So we have answers. So in this case, we have a really interesting conclusion. If the four resistors have a relation R sub 2, R sub 4, if R sub 1 and R sub 5. So resistance of the two product of these two R sub 1 and R sub 5 is equal to the R sub 2 and R sub 4. Then actually the current I sub 3 becomes 0. So there is no current is flowing. So I guess this might be the really interesting conclusions. Okay, this is the end of this practice.